NASA's twin Voyager probes launched in 1977 startled the entire world with their historic voyages to Jupiter, Saturn, Uranus, and Neptune. Both missions are still in interstellar space 45 years later, in order to solve riddles within and beyond our solar system, some of which are more recent than the expedition. Academics are presently employing the Voyager data in a number of ways. The twin Voyager spacecraft from NASA contains an 8-track tape recorder for capturing data, in addition to having roughly 38,000 times less memory than contemporary cell phones, and sending data at a rate that is about 3 million times slower than a 5G internet connection. These spacecraft have been kept as historical objects. Despite this, Voyagers continue to dominate space exploration. While the twin Voyager 1 and 2 probes are exploring, no other spacecraft from Earth has ever traveled to this extent. Voyager 1 entered interstellar space for the first time in August 2012. Making space exploration history. This area between the stars is filled with the debris that was ejected millions of years ago when the surrounding stars died. With the Deep Space Network, or DSN, both spacecraft are still transmitting scientific data about their surroundings. But after years of bobbing around in space, something seems to be wrong with one of the probes. Join us as we investigate the extraordinary Voyager spacecraft's mission and the intriguing messages it continues to deliver to Earth from a great distance. So what concerning information has the crashed spacecraft given NASA? How did this Voyager 1 act strangely all of a sudden? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. The extended job. The close flyby of Neptune by Voyager 2 in 1989 marked the end of the Voyager spacecraft's primary mission. The Voyager Interstellar mission, VIM, a mission extension, was launched after 2 spacecraft had been in orbit for more than 12 years. A senior review of heliophysics was carried out in 2008 by the NASA Scientific Mission Directorate's Heliophysics Division. The panel determined that the VIM is a mission that is highly vital to sustain, and that the program requires more financing and support from the DSN, Deep Space Network. The main purpose of the VIM was to continue exploring the solar system after traveling through the outer planets all the way to the heliopause, which is the furthest point in space where solar energy surpasses interstellar winds and maybe further. In 2012 and 2018, respectively, Voyager 1 and Voyager 2 both exceeded the heliopause threshold. Both spacecraft have been able to observe the interstellar fields, particles, and waves that are undisturbed by the solar wind after passing beyond the heliopause limit. The detection of an area with magnetic bubbles and the lack of any evidence for the projected change in the solar magnetic field are 2 of the most significant discoveries to date. The full Voyager 2 scan platform, along with every instrument on the platform, was cut off in 1998. All platform instruments on Voyager 1 have also been disabled, with the exception of UV spectrometer, UVS. Despite being set to shut down in late 2000, the Voyager 1 scan platform has been maintained in operation to look into UV emissions coming from the upwind side. The UVS data is still being stored even if scans are no longer viable. On Voyager 2 in 2016 and Voyager 1 in 2017, gyro operations came to an end. Gyro operations are employed 6 times a year to rotate the probes 360 degrees to detect the magnetic field of the spacecraft, which is subsequently subtracted from the magnetometer science data. Both spacecraft entered a new domain during the previous decade when they pierced the interstellar medium, the flimsy material that covers the enormous space between the stars. The spaceship continuously picks up new information there. The interstellar magnetic field's strength and direction have astounded researchers, and the new data has even sparked a dispute about the shape and activity of the heliosphere, the Sun's magnetic field. Is the heliosphere a comet-shaped structure, as has long been assumed, or is it more spherical? And does its size fluctuate with the amount of sunspots, or is it more stable? The spacecraft has revealed some enticing information. The long-distance ranger. In 1977, Voyager 1 and Voyager 2 both departed from Earth. They weren't the first spacecraft to arrive at the closest of the large planets. Pioneers 10 and 11 held that distinction. The Voyagers made many amazing discoveries despite being more advanced than the Pioneers. Voyager 1, which traveled less distance than Voyager 2 in 1979 and arrived at Jupiter earlier, found that the planet's beautiful moon, Io, had volcanoes. In 1980, Voyager 1 sailed past Saturn, studying the fine intricacies of the rings and discovering the first nitrogen atmosphere outside of Earth, near the moon Titan. Voyager 2, which stopped at Saturn and Jupiter, in 1979 and 1981 respectively, before traveling past Uranus and Neptune in 1986 and 1989 took a more stunning path. After that, the spaceship began to move towards other stars, according to astronomers. The interstellar medium starts when the solar wind, the sun's outflow of charged particles, ends, similar to a stone blocking a stream. This ionized gas or plasma pushes against the cooler, denser galactic plasma flowing around it, similar to how the tropopause is used to describe the top of the troposphere on Earth. The phrases heliosphere and heliopause are used to describe the hole made by the sun. According to Don Gurnett, a Voyager researcher at the University of Iowa in Iowa City, he really didn't know how far out the heliopause was at the time Voyager was launched. Some speculated that the heliopause might be 5 times closer to Jupiter or even closer to Earth than it is from the Sun. On August 25, 2012, Voyager 1 eventually arrived at its destination at 121.6 astronomical units, or roughly 4 times Neptune's distance, as Gurnett had predicted 20 years before. Yet, the crossing caused such much controversy that it took NASA an extra 13 months to declare the success. Yet Voyager 1 did find some indications that it had passed the heliopause. High-energy solar wind particles vanished, which implies that the remaining solar wind was also left behind. In addition, after Voyager's passage, cosmic rays from outside the solar system, which the heliosphere partially shields, grew stronger. But a lot of scientists weren't persuaded by this information alone. 2 issues were present. The plasma instrument on Voyager 1 was unable to capture the increase in particle density that occurred when the spacecraft left the heliosphere and entered interstellar space due to a malfunction. Second, the magnetic field outside the heliosphere did not point in a different direction as was predicted. According to Krimigas, nature just wasn't aware that it was intended to modify the magnetic field direction because it hadn't read the theorist's writings. The reason why the magnetic fields within and without the heliosphere coincide is yet unknown. The sun helped make Voyager a success. Voyager 1 was startled by the solar storms that had earlier erupted in 2012 as it sped through plasma. This caused electrons to vibrate and produce radio waves that the spacecraft captured. These radio waves frequencies demonstrated that Voyager had actually entered a much denser region, heliosphere, a protective shield. Scientists must investigate this mystery and provide an explanation using information from Voyager and other discoveries. The notion that heliopause is not constant is not new. Researchers have used data from many sources over the last 10 years to comprehend its dynamic character. The Interstellar Boundary Explorer IBEX satellite of NASA, which monitors energetic neutral atom emissions, has helped to shed insight on the position and behavior of this boundary. Voyager 1 and Voyager 2 were the only spacecraft to leave the heliosphere. The Voyager spacecraft only delivered direct observations at a particular place in space and time. IBEX completes their numbers by adding further context. With this knowledge, scientists have created models that forecast how their heliopause may change in the future. In contrast to the solar winds and interstellar medium, which push and pull against one another, the heliopause is a boundary that is constantly moving. However, data from more recent heliopause research refutes earlier conclusions. For instance, the IBEX satellite discovered that the brightening of energetic neutral atoms, ENAs, in 2014, which initially suggested asymmetry in the heliopause over a period of months, was incompatible with the models as it is now. The heliopause appears to have moved greatly in a short amount of time according to data from the Voyager 1 and 2 spacecraft, which may help to explain the enormous time delay between the entry of the 2 probes into interstellar space in 2012 and 2018, respectively. Yet, the heliopause moves, which puts into question theories put forth to explain its stability. The researchers wrote about their findings in a paper that was released on October 10th. They believed that these discrepancies were intriguing and may be challenged. Using NASA's Interstellar Mapping and Acceleration Probe, a new and upgraded satellite that will launch in 2025 and be able to detect ENAs, scientists hope to learn more about heliopause. It is yet unknown what is generating the unexpected behavior of heliopause. Voyager 1's Attitude Articulation and Control System, or AACS, which keeps the high-gain antenna pointed at Earth, started transmitting scrambled data instead of the customary updates on the condition and health of the spacecraft in May of this year. This behavior is similar to electronic aphasia, a condition that makes it difficult to speak clearly. Another intriguing study that needs more details to be fully grasped. The data collected may not accurately reflect the spacecraft's current condition or may have been chosen at random. The engineers were puzzled by the fact that updates from the spacecraft Voyager 1 looked to be in excellent form despite the peculiar circumstance, even though NASA had stated at the time that the AACS may have been in an aberrant state. The ship's radio transmissions were still reliable and strong, showing that the antenna was still pointed at Earth and not where the AACS said it was. Yet, the science systems of Voyager 1 continued to collect and relay data, as usual despite the odd behavior of the AACS. Regardless of what the AACS problem was, it didn't prompt it to activate a fault prevention mechanism that is intended to put the spaceship into safe mode in the case of a malfunction. Fortunately, NASA specialists were able to locate and fix the issue. Once the command to the AACS was delivered, it was found that the AACS had started transmitting its telemetry data using an onboard computer that had long since broken, resulting in the data being jumbled. He was able to send his data home using the right computer after the experts were able to fix the problem. Finding out what prompted the AACS to switch systems in the first place will be the next difficult task. According to NASA, it is possible that the system received the wrong order from another onboard computer. The main cause of this difficulty must be located and corrected in order to prevent additional concerns, even though it is considered that Voyager 1's health is not immediately at dire risk. Throughout the past 10 years, Voyager 1 has been traversing interstellar space, leaving behind the magnetic field of the Sun, which had previously protected it from cosmic rays and other types of interstellar radiation. Similar to how the magnetic field of the Earth shields people from solar radiation and high-energy particles. Without this protection, it is possible that the onboard computer circuits of Voyager 1 are experiencing memory difficulties due to high-speed energetic particles. The Voyager 1 mission is still in operation more than 45 years after it was planned to, despite these challenges. A proud adieu. After all, everything is good, right? All good things come to an end, no matter how successful missions may have gone. There comes a moment when painful decisions need to be made to make space for further progress. It looks like the Voyagers seem to have crossed the finish line after 45 arduous years in deep space. It might be time to call things to a close. Voyager 1 will have to retire in light of the current flaw and malfunction in its onboard processors and AACS. The U.S. Space Agency has started saying farewell to the probe and started to turn down its equipment. It's amazing that humanity was able to send probes into space that lasted for such a very long time, even before the advent of current technology. Two identical probes that were launched at the same time and gave us some of the closest views of the two largest planets in our solar system have since served their purpose. Coming to 2030, the probes will be placed out of mission. NASA is more than delighted with the performance of both the Voyagers and states that they've worked 10 times their warranty. There are still 4 functional components on the first Voyager probe and 5 on the second. They are currently being powered by decaying plutonium, which won't be enough to keep them going for much longer. The battery's output has decreased by 4 watts annually, which has forced NASA to make some difficult decisions. When they gradually began to destroy the probe's components, NASA scientists in 2019 turned off the heater for the cosmic ray detector, a vital component for its operation. NASA will decommission the probes piece by piece with its magnetometer, and the plasma science instrument likely being the final ones. These 2 are kept warm by the extra heat generated by the spacecraft's computers, while the other 2 are suspended from a 13-meter fiberglass bloom that will presumably take the longest to cool. The Voyager's distance from Earth is another justification for ending the project. Now Voyager 1 takes 22 hours and Voyager 2 takes 18 hours to relay a radio signal to Earth. The delay increases by 3 to 4 light seconds per day, making communications more difficult as the probes advance farther from the Earth. The Earth is a noisy place with signals flying all over the place. Amongst all this noise is the whispers from the spaceship become more and more difficult to detect. The accuracy of the hazy information obtained is further questioned in light of the current system glitch, yet it is impossible to discount the value of the 2 probes. These unique views into the vast, largely unexplored universe of space were priceless. Although astronomers may soon be able to travel to interstellar space, it will take another 300 years before humanity can completely leave the solar system. How do you feel about this prestigious end of a glorious era? Do let us know your thoughts in the comment section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.